To introduce our next speakers and resource persons, Dr. Gururaj sir and Subash Chander Goud sir, who will be leading us through this hands-on session. They will be taking sessions hands-on on introduction to data mining and AML workflow, Python installation and application of AI ML in data mining and descriptor selection. Okay, they bring a strong blend of practical experience and deep expertise in AI. Okay, what makes them especially suited well for today's session is their focus on partial application, turning concepts into real-world solutions. Okay, throughout this hands-on workshop, they will guide us step by step. Share valuable insights and help us apply what we learn in a meaningful way. So, Subash Chander Goud from Department of Data Science, School of Engineering, Anurag University. He did his MCA in 2009 from University College of Science, Saifabad, MTech from JNTU. He worked as a faculty in Nizam College too, and he started teaching subjects like IT hardware, mobile communications, AI digital image processing, and distributed systems, and now advanced to big data, data warehouse, and data mining, AI for business intelligence. He takes practical sessions of machine learning tool called Veka. He also prepared manual for installation of Hadoop and its respective modules for big data lab in a stand-alone mode. He published various national and international journals, and few of prominent journals are like artificial intelligence approach for classifying molecular data set using density-based technique with appropriate Euclidean distance measure, future-based pattern analysis using machine learning and artificial intelligence techniques for multiple future data set. So I welcome Subash sir on the dais. And coming to Gururaj sir, Dr. Gururaj Somadigari. He is the Dean IQAC and Associate Professor of Chemistry, Department of Freshman Engineering from St. Peter's College. So, sir has a lot of experience, and he started teaching. He started his career as a teaching as a career for UGC sponsored career oriented program in Chemi Informatics for BSc students at Nizam College, and he joined as a assistant professor in Department of Chemistry in 2007 to teach specially for PG diploma courses in Chemi Informatics, and later on started teaching and mentoring from MSc Chemistry Pharmacoinformatics students, and helped many students for their dissertation works. Sir has experience over 10 years of teaching for PG students and 7 for UG courses. As a resource person, he conducted several hands-on sessions in workshops on homology modeling of proteins, small molecule docking procedures, and AI. He has expertise in teaching basic fundamentals of data mining concepts, ligand-based drug design methods, structure-based drug design methods in theory, as well as handling of practical sessions for the students of pharmacoinformatics. As a mentor, more than 100 plus students projects were completed and as a part of curriculum, and some of them were published in the conference proceedings. He recently published a few of books like spectroscopic identification for molecular organic compounds. So I welcome Dr. Gururaj sir for this session. So give them a big applause, and I hope sir both the speakers, these resource persons will make our sessions very interesting. So I request Subash sir to take over the session.
Respected madams, sirs, and dear students. Is my voice audible? There is an exe file which is being posted in the group. I request every person who is having a PC or a laptop in your hand to download that exe as soon as it is being posted. The moment I complete my theoretical concepts in here, we'll start the practical sessions. After that is being done, there is a small setup for that for the complete things which we are going to explain. One particular exe is being posted in the group, most probably. I should ask Sai Kiran and Srikanth sir to confirm that it is being posted. Once that exe is being done, exe consists of around 94 MB. Once it is installed, I request you to download that one and install that particular exe. It's called Miniconda, and our complete sessions most probably are going to be in that particular single software. It's a kind of an workbench for all the kind of an programming, which we are going to continue for our next of the sessions. And it's simply like it is simply like a kind of a wet lab kind of an workbench which you initialize before conducting any kind of an experiment. It's a kind of an integrated tool. It's called integrated development environment, wherein it's called it is an integrated development environment wherein we have different kind of an plugins we can add into that. And for our kind of an work in the next kind of an slides, I'm going to talk about the theoretical concept related to mining and what is its importance, how mining helps in understanding the patterns, and how we have the Python programming coming into the base of all the kind of an next sessions. What is its importance? So, starting with there are two segments in this complete session. One is learning about mining and machine learning techniques, and the other one is regarding how Python programming runs and how to initialize or write those particular Python programming using Minicoder. So once this is, we will have a small discussion related to this particular concepts of clustering and classification. Complete machine learning consists of two segments. One is called classification, the other one is called clustering. Classification, we have supervised and unsupervised. Classification comes under supervised learning. Machine learning is divided into two segments, supervised learning and unsupervised learning. Supervised learning is called classification. Unsupervised learning, mostly we have clustering methods coming into unsupervised learning. And supervised learning will have a labeled trained data. Like in your perspective, we have molecules, different kind of molecules for different kind of diseases, which you can say. We have one particular kind of Y dependent molecule, depending upon independent kind of attributes. So we are supposed to predict that one. Most probably we can call it as IC50, inhibition constant 50 factor. Mostly we are trying to concentrate on that particular thing, depending on different molecular descriptors. So we use this particular, if you have a trained data, then classification gives us most kind of an output. There are extension of this particular machine learning concepts which are called as deep learning methods, which also has the solution like AI with the deep learning mechanisms. AI is not only deep learning, we have other mechanisms also into AI. And this particular classification is extended by the deep learning methods. And you have predefined classes which are being given into this particular learning mechanism, wherein it tries to have, example, you can also say the spam detection, some of the spectral images like satellite images, we call it as hyperspectral images, wherein you can identify each satellite image by using a spectral signature methods. So you have a specific label for each pixel there. Same way, we have IC50 for the molecules which we wanted to predict. We use that particular IC50s in order to predict for the kind of molecules for whom we don't have any experimental kind of IC50 values. So we use the classification technique generally when we have trained labeled data. And so we collect the data set initially, what kind of data set or what kind of drugs you are trying to work out, for which you have the IC50s, inhibition constants, keeping that as the kind of prediction variable. We try to use the other kind of molecular descriptors as the base or independent variables to predict these particular IC50s. Then the training the model is one interesting fact here, wherein training the model comes into the picture, wherein you have different classifiers in classification techniques. See, we have types of classifications: binary classification, yes or no, whether it is suiting that particular disease or not. Then multi-class classification, whether we want to predict the IC50 range you wanted to predict, then it becomes multiple ranges of IC50. Multi-labeled classification, you wanted to label each particular kind of an molecule into separate families, then comes your multi-label classification. So we use this particular training the model. We have different kind of an classifiers which are available free of cost. You can directly download them, use them, predict, and then utilize them for your further kind of an investigations. So after that, we have another thing which is called as test. So here the test here is we have a complete data set of 100%. Generally, in mining or machine learning techniques, what we try to do is we try to take 70% of that particular data set as training and keep 30% as test molecules. Example, you have 100 molecules which consists of independent 100 IC50s. We divide that complete data set along with the IC50s as 70% separate and 30% separate. Then we try to use this particular 70% molecular descriptors along with the IC50 value, use the test kind of an molecular descriptors, predict the IC50 from that 30%, then we measure the classification accuracy. The best kind of a classification accuracy where you get, mostly it is suggested it should be more than 0.7 or it's called 70% classification accuracy. If it is more than 70%, we try to say that it is a good model. If it is more than 85, 90, good. More than 95, you are supposed to see that there are false positives coming into the picture, wherein they are not supposed to come into that segment. You are trying to classify them. So model tries to overfit in this particular place. So see that particular model. Model is nothing but a classification algorithm, just like these things. So we have different kind of classification algorithms which are available. We can use them, and you can write your own Python scripts in order to load these particular thing. How to write, I'll show you in the next kind of slides. So we have these particular logistic regression. This regression tries to use your different kind of descriptor values to predict the IC50. K nearest neighbors is one particular place wherein we try to capture the nearest kind of neighbors based on the distance metric from one molecular descriptor to the one molecule to the other molecule based on its descriptor values. Like we have 10 descriptor values, molecular weight, molecular bond angle, different kind of properties are there. So we use these particular values and calculate the distance from one particular molecule to another molecule. Based on the nearest neighbors, we try to group them and say they are similar. So we try to assign they may be belonging to the same kind of a class. So we try to say they are having a similar kind of an IC50 value among these particular molecules. Decision tree, we build a tree kind of a structure to classify, just like how we have a family species being classified, like your NCBI, you have different species, subspecies, how they are classified. We build a tree structure based on the properties like descriptors and their values, how much they try to support in making a decision. To construct this, they use statistical properties, statistical methods to decide which descriptor to sit at what kind of a place or what branch to guide the decision tree, whether it is correctly classifying or not. Random forest is also an extension part of decision tree. Support vector machines use a kind of a principle of 3D or n-dimensional vectors which are being drawn in multi-dimensional concept. And we also have naive-based neural networks. This is what I was trying to talk. Classifications or classifiers are being extended by deep learning methods, which are giving you more amount of accuracy. And that's where we have deep neural networks, quantum neural networks coming into the picture. We have pico neural networks also coming into the market. So there are capsule neural networks also which are coming into the market, wherein the architecture is something like a kind of a meshy kind of a structure, wherein each particular node inside that will be having an activation function, the smallest part, which is something like a neural system. So they construct an artificial neural system, which is an extension of these particular neural networks. Neural networks was used around 10 years back. It was very hard, so that each neuron is supposed to be written and it is supposed to be implemented neuron by neuron. Now we have a extension of these particular ready-made available kind of a neural networks which you can extend them, implement them and then use them. Other than this, what are the advantages of classification is they give you high accuracy with respect to the data, training data when it is available. When training data is not suitable, I don't suggest you go with the classification. Training data should be at least 70%, test data should be 30%. Now, it is very easy to perform the evaluation because metrics are very easy. We have different statistical metrics which are available also. And they are being used for prediction problems. Like you can use them for, in your context, it is used for estimation of IC50. Some places we use it for estimation of satellite image pixel classification. Some places we try to use it for estimating whether an email is a spam or not. Some places we try to classify whether a user is a threat or not. So we have different applications. They use these particular classifier algorithms to justify whether it is a spam or not. So it is simply using these algorithms to classify whether it is a kind of a good mail or bad message, whether it is a repeated, it is a spam. It is going to use these particular algorithms. Here we are, under our context, it is used for classifying this particular molecule, whether it belongs to the same kind of a targeted drug or not. So we use these algorithms. And the place where the next study, which is very interesting, wherein labeled data is not there, we don't have suitable amount of labels or IC50s, I suggest you go with the clustering mechanisms. And it is quite interesting because we don't require any labeled data, like IC50s are not required. Still, in order to estimate the IC50, we require a small training sample to say what is its range and all these things. So where the labeled data is not there, clustering mechanisms are better suitable. And it tries to group the data, or it tries to give the, you give the data, it tries to group it into different kind of classes. That's what clustering is going to make. Classification, we have a labeled data, we know which class it belongs to, we know which molecule belongs to what range of IC50, then we can apply the classification algorithms. Clustering mechanisms are applied when we don't know that particular molecule belongs to what class, what is its label or which group it belongs to. There you can apply these particular clustering mechanism, and you can have these particular things for grouping the different continuous spectral bands, like how you try to go with the spectroscopy, different spectral ranges you wanted to clarify for any particular molecule, you can use this particular clustering mechanism. And we have the data being given similar fashion, but once the data is given, the similarity between one point and the other point is going to be calculated. These similarities are dependent on different spectral measures. The most standardized spectral measure which we use is an Euclidean distance, which is defaultly used in all the kind of clustering mechanisms. It calculates the point to point, how much is the distance, and based on that distance, it tries to group the rest of the other molecules. When they find that these particular group of molecules are one particular set, they try to make it into one group. It's called a cluster. And the second group, it depends on our input, that how many clusters you wanted to make. You're supposed to predefine in the particular data set how many clusters you wanted to make, and based on that particular input, it tries to divide the complete molecular data set into different segments. And once the form of these particular clusters are being done, you try to evaluate what these particular clusters behavior is and how they try to behave, and what is the properties based these particular clusters are being grouped into one particular place. There are different types of clustering mechanisms also, called as partition based, which is my favorite part. Reason because you try to define the partitions based on its position. You try to say they are into one particular partition, and you have hierarchical method, like you wanted to have a hierarchical fashion of dividing the data into these particular molecules into one particular set of disease. These are into another disease, and these molecules suit this particular place. You can go with the hierarchical. Density based is more complicated. Reason, you wanted to find out the density of these particular points where they are grouping into one single place. So the more the density, the more the kind of groups are being formed. So the nearer kind of clusters, it is hard for us to separate those particular molecules if they are into the nearest kind of. Now model based is you try to give a mathematical equation and say if these particular molecules are following these mathematical equational kind of attributes, then you try to group them. Now common clustering kind of mechanisms of those types of clustering are these things. K-means hierarchical clustering is one particular thing. You have two parts in hierarchical clustering, agglomerative and partitioning other one. DB scan, which is density clustering, density based clustering mechanism. Mean shift algorithm is one particular place. Based on the mean of the properties, it tries to shift its particular cluster center. Based on that shifting, again the grouping is done. And Gaussian mixture model is a particular equation based, like I was saying you, model based clustering mechanism. It's purely based on Gaussian equation actually. The advantages of this, I've said you, we don't require any trained labeled data. We don't need to depend upon what classes are there, how many classes are there, what is its use and all these things. And it also helps us wherein we are required to identify a specific pattern in a data set. We use these clustering mechanism wherein we have least information regarding these particular clusters or least information regarding these particular molecules according to your study. And yes, it's only a particular classification versus clustering, what they try to do and how they are. Yeah, applications, we have different applications for these particular classification and clustering mechanisms. So we can use them in medical diagnosis. We can also use them in drug discovery, like what is our particular motive of today's session. We can also use it in remote classification or remote sensing, like satellite images. Also they use this particular classification and clustering mechanism. And market-based trend analysis, like predicting how the a particular grocery store stocks are changing. Based on its change, they try to pile up more amount of stocks. So these are all the applications of the clustering and classification methods. Now it's only a kind of a small idea which I have given you in these particular slides. The next slide, next kind of an presentation, we have yeah. So to implement all these particular what do you call mining or classification techniques, we depend on a particular programming language. In our case, we use Python. There are specific reasons why we use Python. And can I have a clarification? Cyclin, it's being installed in all the systems? Everyone installed the Miniconda? No? Wi-Fi is not. Okay. Okay.
every session అంటే కొద్దిగా ఇన్స్టాలేషన్ నెట్వర్క్ ఒకసారి ఎంతమందికి ఇష్యూస్.
How many people are facing network issues? Kindly raise your hands.
Almost everyone.
Almost everyone. That row has been fixed, no? Huh? No? You are not getting? We bought one more router also. Admin 1, admin 2. Admin 1, admin 2, Windows 2026. No? This side also, admin 1, admin 2. You are not able to connect, everyone. Just give us 2 minutes, we'll fix. Okay? if anybody is having their own hotspot, please connect to your laptop.
Right? This actually gives you the practical insight. That's all the theoretical part which I have said you, how you can apply for your drug discovery, what methods and all these things. That's only a kind of a glimpse that how you can implement your molecules and how you can apply different machine learning techniques on your molecules which you are going to decide. So to make that particular things possible, you require a particular programming language. We'll start having the discussion regarding how Python works and how you can write any code segment in Python. So I'll show you how Python tries to compute, what data types it is going to have, what are the various kind of an language syntax you are supposed to give. Once these particular short discussions are done, I'll show you how in that particular miniconda, how you can try to execute your molecules. We have some particular data set. I think I also ask Giri to share this particular Excel sheet or CSV file regarding the training data which we are going to apply practically. EXE, not EXE, the smile notations and all these things. Right. So, he is Rasam, the inventor of Python program or Python programming language. And he tried to name this particular language based on a particular movie show. It's not something related to animal. It's a movie show based on which he tried to give that particular name. And it's called high-level language. And the language syntax for Python are quite easier compared to Java or C, any programming languages. Python is very easy to learn. You can learn it in very short form, in a short duration also. And you can use them for the web applications. Even all of you have Gmail, right? Gmail runs on Python actually. Gmail runs actually on Python. So it's a web application which they try to use. You can make a user interface out of the Python programming language also. And next thing is the importance of Python programming language is it is an interpreter based language. Any programming language, you need to have a compilation. There will be an execution engine which tries to compile the complete code and then generates the code to make it understand to the CPU to execute it. But in here, Python, it tries to compile every line by line. So one line you give an instruction, it compiles, gives the instruction to the machine, that gets executed. The next instruction, it gets compiled, then it executes. So line by line execution, that makes Python much more faster than any other programming languages. And it can also be run on Linux, Windows, or Python or Mac, any particular place. So you don't have any operating system dependency, whether you use a MacBook, whether you use Linux-based different flavors like Ubuntu or SUSE Linux or any other Linux. And we can also run it on Windows because we are addicted to Windows. So we can also run this particular programming language on Windows. So there is no cross-platform. Once you write code in Windows, you cannot say it won't run on Linux. It can be run on Windows. At the same time, it can be run on Linux also or any other platform also. These are the features of why Python is being mostly used in the market. Free and open source, you need not pay anything. It's open source licensed kind of an agreement. And later, you can also have object-oriented programming. Like Java, they have also implemented object-oriented programming features. You can use this feature. You can also emit this feature. There are some language constructs. If you use it, it becomes object-oriented programming. You don't use it, it becomes a formal language. It's called scripting actually. Programming languages are of two types. One is a normal programming language. Another one is a scripting. Scripting simply I can say is you have a particular switch any place. You try to switch it on. You have one particular light or any fan being rotating. So this particular switching on is called an event. So the moment you make an event, there will be an action. So it's called scripting. So scripting languages are faster than programming languages like Java or .NET or any other kind of hash or JHash, any other programming languages. And you can also integrate these particular Python scripts with other programming languages also. That's pure technical if you have an application to application communication. These are different kind of places wherein it can be used. Our particular part is to use this particular segment, machine learning and AI implementations. All the deep learning methods or pico neural networks or deep neural networks or quantum neural networks which are running in the market are all based on Python programming only. Got it? And we have, as I said you, 2 different flavors. I can show you how you can download Python. You are interested, I've kept you one particular segment wherein you can download Python directly, install it and you can work it. But according to our requirement, according to this particular schedule, there is a dependency between this session and the other session also, wherein you require some plugins to be installed, some other kind of libraries to be installed. That can be easily done in Miniconda. So we have suggested you to go with Miniconda, which we have already posted in that particular WhatsApp group. Once it is done, just clicking it, it gets installed by next. Nothing you are supposed to do. Once it is installed, raise your hand, I'll say you what you are supposed to do. Anyone got installed?